In this video, we're going to secure the order history backend. So the order history functionality is working. However, the REST API on the backend /API/orders is unsecured. All right, so we have the front end stuff in place, but the actual backend REST API is wide open. Anybody can access that backend API. And so what we'd like to do here is secure the backend REST API. So the /API/orders should only be available to logged in users. So they'll have to log into the actual application first before they can actually access this backend API. So the get for /API/orders. Here's our development process. In step 1, we're going to add the Okta Spring Boot Starter to the Maven pom.xml file, and then we'll create an app at the Okta developer website. Next, in the Spring Boot app, we'll set up our application properties, and then finally, we'll protect the endpoints in the Spring Security configuration class. Alrighty, step 1 of adding the Okta Spring Boot Starter to the Maven pom.xml file. So Okta provides a Spring Boot Starter for OAuth 2 and OpenID Connect. It simplifies the integration and configuration of Spring Security and Okta. So here's the pom.xml file and the entries here for the group ID, artifact ID, and the version. And this is provided by Okta. If you'd like to get more information or more details on this Okta Spring Boot Starter, go to the link here that I have on the slide. In step 2, we're going to create an app in the Okta developer website. So we simply visit the website. We create a new application integration. For the platform, we choose web. For the sign-on method, we choose OpenID Connect. We hit the create button, and then it'll give us some details here. And so we simply give an application name. We can give any name that we want. And then at the bottom here, we will set up the login redirect URI. And I'll cover all of this in the coding video. I'll kind of walk you through the process of getting into the website, filling out the forms accordingly. For step 3, in the Spring Boot app, we're going to set the application properties. And so we'll set up the properties here for okta.oauth2.clientID. And we'll also do a similar thing here for client secret and for .issuer. And you may wonder, well, where can I get this information from? Well, you'll get this from the Okta developer website. Once you create that app, then you'll have the entries here over on the right-hand side: client ID, client secret, and Okta domain. And you can easily copy paste that information from the website over into your properties file. And I'll show you that whole process in the coding video. Your Spring Boot application will use these properties to verify and validate the JWT access tokens. Alrighty, let's do a quick little refresher on OAuth 2. So there's some key players here: a resource owner, resource server, client app, and the authorization server. And they all kind of interact and work together. And so let's kind of just take a look at this and do a quick refresh. The one item we'll look at is a resource server. The resource server is the app that's hosting our protected resources. So in our case, it's our Spring Boot app that's hosting our REST APIs. The resource server manages security using the access tokens, JWT. The access tokens are validated with the authorization server, which is Okta. So now let's kind of pull this together. On this diagram here, the resource owner is the actual end user. All right, they'll enter their user ID and password. They'll make use of this client application. In our case, it's a Angular front-end application. And then the resource servers are Spring Boot application, holding our protected resources, those REST APIs. And then finally, the authorization server is Okta. And here's the sequence diagram so you can kind of see the whole interaction between these different players. So the resource owner will log in with their credentials, their user ID and password. The client application will send those credentials over to the authorization server, which is Okta. Okta provides an auth token. We use that auth token to request an access token. And then Okta will provide us that access token. The client app will use that access token and send it over to the resource server, which is our Spring Boot application. Our resource server is going to verify, validate the token with the authorization server, Okta. And if everything checks out okay, then it'll provide access to the protected resource. So again, remember, the resource server is our Spring Boot application, and it says, hey, I have a token. Is this a valid token? Then based on our security rules, then we can provide access to that given protected resource. Now, with the client sending the access token, they're going to send the access token as an HTTP request header. So our Angular application, when they make a web request, then they'll actually send over this request. They'll also set up a special request header, authorization, bearer, and then the actual reference to the access token. All right. So this is something that our Angular application will have to send over. Now, at the moment, our Angular app doesn't send this. We'll add this in some future videos, but that part will need to be in place for it to fully work end to end. At the moment, we're simply focusing on the back end of securing the back end REST API. Once we get the back end REST API secured, then we'll focus on making the updates for the Angular app. But don't worry, I got you covered. We'll cover the back end stuff and the front end stuff in these series of videos. Okay, finally, step 4, protecting the endpoints in the Spring Security configuration class. So we'll just set up our package and our imports here. We'll set up this configuration, extends web security configurer adapter. We override the configure method for HTTP security. And then we're going to protect this endpoint /API/orders. So here, what we're going to do is we're going to protect the endpoint, and it's only accessible to authenticated users. So note here for .ANT-matchers, it's /API/orders/**. The ** will basically say, apply this rule for this path and all sub paths recursively. And the .authenticated piece says, hey, this is only accessible to authenticated users. And then we have OAuth2 resource server. So basically we're going to configure ourselves as an OAuth2 resource server. So we're providing support for that. And then we have .jwt. So this enables JWT encoded bearer token support. So when this information is passed over as part of the HTTP request header, then this gives us functionality to process that header, read that information, and process that JWT token accordingly. Now, one thing I want to kind of just step aside here, make a small digression. JWT, that's how I reference it. Online, you'll also hear people refer to this as JSON Web Token. You'll also hear people refer to it as a JOT. You can call it JOT or JSON Web Token. Totally up to you. Doesn't change the technical stuff, right? Everything still works as desired. Okay, back on track. And then we add support for the CORS filter. So we simply say http.cors. And that's basically it as far as the Spring Security backend coding for securing this REST endpoint. So what we'll do is we'll move into the next video and we'll go ahead and start writing the code. So I'll see ya in the next video.